So this presentation will cover the famous egg dropping problem and how to solve it efficiently using DP. We will break down the problem, the approach, and the code step by step. So the problem involves determining how to drop eggs from different floors to figure it out highest safe floor for which an egg can be dropped without breaking it. The aim is to do this in as few trials as possible, particularly when working with multiple eggs and the floors. Okay, so here the constraints. So for example, you have an X and your building has K floors. So the challenge is we need to minimize this number of trials in the worst case scenario. So the approach is right. So here we use the DP, that is a dynamic programming, where each entry DPI comma J denotes minimum number of drops needed with IX and J floors. Okay. So here the key is to optimize our egg drops by calculating worst case scenario for each possible drop, taking the minimum number of trials. Okay. So here the base case, right? 0 floors means 0 drops, and 1 floor means only 1 drop, right? So these are the base case. So the recursive formula we try to use is this. So dp of ij equal to 1 plus min of maximizing dpi minus 1 x minus 1 dpi j minus x for x in range of this. So, but what actually this formula means? So it's basically explanation when we talk about this minimum, right? So we want to find the floor x that minimizes the number of trials in the worst case. Therefore, we take the minimum value over all possible floors, right? So that's why this minimum. And when it comes to max of this, so what we are trying to do, for each floor, we consider two scenarios. Okay, so that is if when we drop the egg from that X floor, the egg is break. So that's why now we need to check I minus 1, we have I minus 1 X in hand, and we need to check over remaining X minus 1 floors. Okay, so that is the, and second one is right. So when we drop egg at X floor, so that egg didn't break. That means the floors we need to check is our top floors. That is J minus X floors are pending because there are J floors overall. Okay, so that is. So when it comes to this overall max thing, right? So we can take the minimum of these two scenarios because we are interested in the worst case number of trials needed. This ensures that our solution is robust against the worst possible outcomes. So here is the implementation. So if you look into this base case, right? So basically the code, basically the first initializes the table with the base cases. 0 floors require 0 drops and 1 floor requires 1 drop. It then fills the table by iterating through eggs and floors. Okay. So base case, as I mentioned, 0 floors, 0 drops, 1 floor, 1 drop is required no matter how many eggs we have. Okay. So, and this case, right? So this part of the code basically for 1 egg. Okay. So we have no choice but try to each floor one by one. So the number of drops equals the number of floors. So this one is the we have to navigate through all the elements in the DP to fill them. Okay. So since already we tried base cases, which includes 0x and 1 egg. So now we need to travel 2 to n plus 1, and j is the floor number, right? 2 to k plus 1. Okay, so dp of I minus 1 x minus 1, that is egg breaks and check the floors below. dp I j minus x is egg doesn't break at x floor. Now check the floors above. Okay, so the same formula, well, that's what we did, right? For I comma j, so what we are trying to do, we are trying to find out the maximum plus 1 because we drop the egg in the x floor. That it's going to be considered here. Now the dp of ij is the minimum of this result and dp of I comma j. Okay, so this is the final one. So yeah, so here you remember I is the number of eggs and j is the number of floors. Okay, so for each subproblem, the result is calculated by trying every floor x from 1 to j and taking the worst case number of drops plus 1 for the current drop. This is done for all the floors and we take the minimum of these values. And the time complexity, we loop through two things, right? All xn floors. So, so that's why it is O of n into k square. So for each floor, we try all possible drops. So space complexity is O of nk, since we need to create a DP table of n cross k to store the intermediate results. Thanks.